Okay, so basically then this is your assessment for the first half of the unit. Okay, make sure you look at the point values for all of the questions. Okay, do the appropriate amount of work for that number of marks. Okay, if something is out of 3 marks, it's givens, a formula, maybe manipulation, and an answer. Okay, so it's not going to be much. Okay, if it's 5 marks, obviously there's going to be a little bit more to do. All right, so on number 1, we're talking about a blender. So if you've ever made a smoothie, okay, those little blades spin really, really fast. Okay, they're moving at 21 meters per second, and they are 0.053 meters apart. We're looking for how much time it takes them to make 1 revolution. So this question is testing whether you understand what the time for 1 revolution is called and how you calculate it based on the 2 things you are given there. Okay, number 2 is similar. A horse races around a circular track in a time of 118 seconds. So that's the time for 1 lap. Okay, at a speed of 17 meters per second. You're looking for the radius of the track. Again, nothing terribly complex there. Okay, number 3, just because this is contextual or dependent on you understanding the context, back in the day, sound and data used to be recorded on magnetic tape. Okay, so it was on these reels. You could get cassette tapes, you could get 8-track tapes, were like this big cartridge that you could use in a car, okay, or you could just get big spools. Okay, so it's essentially like you're winding up something onto a roll. Okay, that's what they're doing in this question. So this really thin magnetic tape is just being wound up onto a roll, kind of like if I did this. Okay, so this is my spool. Okay, the tape is my spool, and it's just winding the tape onto the spool like this. All right, everyone kind of follow what that one's like? Okay, so it's coming from a supply reel to a take-up reel. So on these old tape machines, there was another reel over here. This reel would take up, so it would wind, and the other one would spin the other direction and let the tape come off. Okay, so it's transferring tape from one spool to the other. We're only worried about the spool it's going on to. Okay. So it's moving at 0.191 meters per second. The radius of the take-up wheel is 0.0762 meters. We're looking for both the magnitude and direction, which is easy, okay, of the centripetal acceleration of the tape as it is wound onto the reel. Okay, so you're looking for centripetal acceleration, and it actually asks for direction. Okay, so you actually have to write it down. It doesn't require you to do anything other than write the direction down, because of course we know what direction centripetal always means. Okay. For number 4, okay, you got a race car going constant speed around a circular track, okay, whose radius is 2.6 kilometers. Okay, I would say be mindful of units here. Okay, you're given something in kilometers and then something else in seconds. Okay, so the car goes once around the track in 360 seconds. What is the centripetal magnitude of its centripetal acceleration? Okay, number 5. How many people have ever seen or played pinball? This is another kind of contextual one. Okay, so pinball machines had basically a metal ball, and you would pull a spring-loaded plunger out, and you'd let it go, and it would hit the ball, and it would go around this big corner, and then come into the game, and you would push buttons to activate these little flappers. Okay, and you could hit the ball around, and you hit things inside the game that would give you points. Okay, if the ball ever got past the flippers, then you lost, and you only got like 3 chances. Okay, so that's how pinball works. We're only talking about the first part, where the ball is launched, okay, and it goes around the circular part. So we're dealing with like this sector of a circle, okay, in that question. Okay. Right, so the centripetal force is given, and you know the radius, and you know the mass. You're just looking for the speed. It's not a difficult question. Okay, it doesn't even really require you to do very much. Okay, it's just context. Okay, number 6, child's twirling a ball on a string. So like what I've done at the front here numerous times with the roll of tape. Okay, in a horizontal circle, you know the radius, and you know how long it takes to go around the circle. You're looking for centripetal force, and then you're asked in B, if the speed is doubled, does the centripetal force double? And if not, by what factor does the force increase? So part A, you have to do a calculation. In part B, you don't necessarily. Okay, I'd be satisfied if you could just explain to me what happens, but if you want to do the calculation and then explain, that's also fine. Okay, but 4 marks are for the first part and 3 marks are for the second part. So your explanation in part B is 3 marks. Okay. Number 7, at what angle should a curve be banked if its radius is 150 meters and you want to go at 25 meters per second without relying on friction? So you got a banked curve question there. Okay. And then number 8 is also a banked curve question. Okay, this time you're given the angle, looking for the speed. Okay, in both of those curves, there's no friction. Okay, number 9, you got a vertical circle question where you're producing apparent weightlessness. Okay, and you're looking for the radius of the circle. Okay, number 10, also a vertical circle question going over the top of a hill. Okay, and you're looking for the centripetal force and the normal force that acts on the cycle. And number 11, okay, another vertical circular motion question for a roller coaster at the bottom of a vertical circle. Okay, you have to calculate how fast the roller coaster is traveling there. Okay, if they feel a force equal to 3 times their weight. We did a question just like that in class, but it was 2 times the weight instead. So you've done one like this if you want to look back in your examples. Okay. Number 12, okay, you've got a wrecking ball, okay, that swings at the end of a 15-meter cable, okay, and at the lowest point in the swing, it's moving at 7 meters per second, so another vertical circular motion question. We're just dealing with the bottom of that vertical circle, okay. You're looking for the tension in the cable, which is equal to or replaces normal force if you're dealing with a track. And then 13 is your unbanked curve questions, the only one that kind of goes out of order, because we did unbanked curves before we did vertical, but it's an unbanked curve question for 13. Okay, questions on any of those? All right, you should be able to get a good portion of this done today. I'm going to give you the whole class to work on it. I would imagine a lot of people will probably finish. Okay, all right, get to her there, guys.